Welcome back to the classroom. My name is Mr. Wong, and today we'll be covering the Module 7 Inquiry Question 1 on electromagnetic spectra. This question goes to the 2019 HSC Physics paper, question 22. It says, spectra can be used to determine the chemical composition and the surface temperature of stars. We need to describe how spectra information about three other features about stars. Okay, so what we can do is one feature at a time. So we can look at feature 1. And if you recall, what we mean by spectra is it could be the absorption, it could be the emission spectra. So different kind of positioning of the spectral lines can tell us different information. So feature 1, spectra can tell us about the density of the star. Okay? So when it comes to the density, we know that if a star is really, really big, so the particles are really far spread apart from each other, the emission of light from the center core, when it emits light, it's less likely to hit the gaps or hit the electrons to cause transition. So the less dense the star, the thinner the lines, and the more dense the star, the thicker the lines. Okay, so talk about the thickness. The thickness of the spectral lines or spectral lines will indicate the density of the star. Less dense stars will have narrow lines, whilst highly dense stars thicker lines. You don't have to explain why that's the case, because this question is only asking for a describe. So that's feature number 1. Feature number 2, we can talk about the velocity of the star. So rotational and translational velocity. We know that this all comes down to the Doppler effect. Okay, so if it's about translational motion, we will see that the spectral lines, if it's coming towards us, it'll be more blue shifted. If it's moving away from us, it'll be more red shifted. Okay, so if we look at translational velocity, a red shift indicates the star is moving away from us, and then a blue shift indicates that the star is moving towards us. Okay, next one is rotation. So for the rotation, remember, with the rotation, you can imagine the star is spinning, and this only applies for stars near us. If the star is rotating towards the observer, we will indicate that as a blue shift, and if the star is rotating away from us, that indicates a red shift. Okay, so we can also say applies to nearby stars. Okay, a red shift indicates it's rotating towards us, or away from us, sorry. So red shift indicates rotation away from observer, while as a blue shift indicates a rotation towards the observer. Okay, so those are our features. Okay, so that pretty much concludes what we need to do. One final thing you could mention is with the rotational and sorry, I said 3 features, but we have 2 features. If you count the rotational and translational as different, that's your features there. With the rotational, you can also tell if there is rotation because there are blurry lines in between the spectra. So imagine you have these lines here, it's quite distinct, but there's sort of like these fuzzy lines in between that would also indicate there is rotation. The reason being is because the planet is rotating, so the star will look like it's either looking a little bit closer towards us or a bit further away from us, so you can tell that as well. Okay, so the spectral lines that are less sharp, we could even say blurry, will indicate that the star is rotating in the observer's perspective. Okay, and that's how you do this question, how we describe spectral information with other features besides temperature and chemical composition. Hopefully you found this explanation video useful in terms of features of stars. If you did, give it a like, and I'll see you next time.